Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 26 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 611, valid triangle number. So let's read the problem statement. So we have given an integer array nums. We have to return the number of triplets chosen from the array that can make triangles if we take them as side lengths of a triangle, right? So first, what is valid triangle, right? So let's read this. A triangle is a valid if sum of its two sides is greater than the third side, right? And if let's suppose three sides are a, b and c, then three conditions should be met. That is, a plus b should be greater than c, a plus c should be greater than b, and b plus c should be greater than a. So let's say this is my triangle. Here it's a, b and c, right? So this a, right? So this a value, it should be smaller than the sum of b plus c, right? So b plus c should be greater than a. Same way, this b, it should be smaller than the summation of other two sides a plus c, and this c, it should be less than summation of other two sides. So if this is the case, then our triangle is valid, right? So here, if you see this example number 1, so here 2 plus 3, 5, 5 is greater than 4. Good. 2 plus 3, 5, 5 is greater than 4. We are using this second 2 this time. First we are using this 2, right? And here 2, 2, 3. So 2, 2, 4, 4 is greater than 3. Good. But this is not valid if I choose 2, 2 and 4 here, right? So this is not valid because sum of two sides, it should be greater than the third side, right? But this condition is not valid, right? So here 4 is equal to 4, right? So that is why output is 3, right? So from here I can do one thing. We have to just check all the values, right, one by one, right? So here if you see this example number 2, so here we are getting 4. So let's do one thing first. Let's sort this nums array, right? So if I sort this nums array, I'm going to get something like this: 2, 3, 4, 4, right? So now let's say if I fix my a here and b here, then this is my c, this can be my c, right? This is valid. 2, 3, 4, this is valid, right? And if I select this as my c, then also this is valid, right? So a, b, this as my c, a, b and this as my c, so both are valid, right? So here 2, 3, 4, and here again 2, 3 and the other 4, right? So these two. Now after that, let's say I start my a from here, and let's say I fix my b here, and then I take next as my c. So is this valid? Let's see. So 3 plus 4, 7 is greater than 4. Yeah, this is also valid. So 3, 4, 4, right? And also if I select this as my a and this as my b, and that is 2, 4, 4. So 2 plus 4 is 6, 6 is greater than 4, right? So this is valid. So here what we are doing, first I have to do the sorting, right? So if I'm going to do the sorting, so definitely the c value that I'm going to pick, this value is going to be greater than a or b, right? Or it can be equal to, right? It can be equal to 2 to 2, right? If this is my c, or it can be greater than this. Here a is 2, b is 2, and here's 3, bigger, right? So first I'm just doing the sorting on this, and because if I do the sorting now, so then this case will not arise. Like here I have 8, and the next I am picking here 2, 2, right? So I'm first making sure that whatever the c value that I'm going to take, it is going to be bigger one only. So if I want to take it bigger, right? So what I want to do, I want to keep these two smaller than this c or equal to c, right? So here, that's why I'm sorting this. So once I sort this, so I'm going to get something like this. Okay, sorted. If I fix this as my a, then after that I'm going to check this as my b and c. Then I will keep my b here and c here, right? Done. Then after that I'm moving my b here and c. So what I'm saying here, we have 2, 3, 4, 4. So I'm going to run 3 loops. So my I loop is going to run, since we have to take 3 elements, right? So my I can only run from this to this, right? My j, right, if my I is running from this to this, my j can run from here to here only, right? Because after a we need b, and after b we need some c, right? And my c can run in this range only, right, until here. So now let's understand. So first, if I pick my a here, then next time I have this option, I'm picking this as b and I am picking this as c. So this is valid, right? And next time, if let's fix this b here, and next time I'm picking this as c, right? So these are valid. Now in the next iteration, what I'm going to do, I'm keeping my a here. Now my b is going to move here and c here. So here, see, this is also valid, right? So first a, b and c, that simply means 2, 3, 4, right? Then a, b and this c, so that means 2, 3 and this 4. Then after that a here, and then b and c, that means 2, 4 and 4. Now after that This is done. Now after that, in the end, I'm going to, after that b, I can't move this b further, right? Because if I move my b here, somewhere here, then it is going to out of bound, right? So what I'm going to do in the next case, I'm going to shift my a here, and then if my a is here, definitely I have to pick the next element as b, and this as c. So here also I will check a plus b, 3 plus 4 is greater than 4. Yes, this, right? So it's very simple, right? If you see the approach one, so what I'm doing, I'm first sorting this nums array, and once I sort it, then I'm going to create one variable count, and here I'm just running 3 loops. I is from 0 to n minus 2, because we need 3 elements, right? J is starting from I plus 1 to less than n minus 1, and k is starting from j plus 1 to less than n, right? So I'm running 3 loops, and in all the loops I'm just checking if nums of I plus nums of j, right, this summation of these two should be greater than nums of k. And here I have already sorted my array, right? So this is the thing that I'm checking, and then if this is the valid case, then I'm just doing count plus plus. That's it. So this is a solution, right? So here in this solution, you will be able to pass this solution as well. You can just simply refer this and write it. So for this one, you are going to get the time complexity as O of n log n for this sorting part, and here you are going to get you are running 3 loops, so you are going to get n cube. So overall time complexity is going to be O of n log n plus O of n cube, right? So this is approach 1, right? So let's see some better solution than this, right? So you will be able to pass the solution with this, but let's see some better solution, right? So in the better solution, what I'm going to do, I'm going to do the sorting is very important for this problem, right? And then here, instead of O of n cube, I'm going to solve this problem in O of n square. So I'm going to implement the 2 pointers approach. So now let's see some good example for this. So let's say this is the example. I have 2 3 4 5 and 6. This is already sorted, right? So here in this, what I'm going to do, I'm going to fix this as my k, right? And then I'm going to start my j from here, j from k minus 1, right? And I'm going to start from my I from here, right? So here what I'm going to do, in this, k is fixed, I'm taking for this element, right? And here I is here and j is here, right? So now here I'm going to do the addition of these 2 plus 5. So here tell me, 2 plus 5, it is greater than 6. Yes, 7 is greater than 6. So now here 2 and 5, right, sum of two sides, it should be greater than this third, right? So if 2 5 6 is valid, right, then same way 3 5 6 is also going to be valid, 4 5 6 is also going to be valid, right? Because I'm just incrementing the I value, right? And all the values are in increasing order. Same, or can we increase in increasing order, right? So these values can be in increasing order or same, like this, right? Can be same or increasing order, right? Array is already sorted, so all these are valid, right? All these are valid. So now here in this case, this is my 0 index, 1 index, 2 index, 3 index, 4 index. So in the count, what I'm going to do, I'm going to create one variable count. In the count, I'm going to store what? I'm going to store j minus I value. So what is j? J is here 3. 3 minus 0 is nothing but 3. So in the count, I'm storing 3. Done. So these 3 are the valid ones, right? Now after that, once this is done, then what I'm going to do, I'm going to move my j here, right? My k is fixed here. Now I'm moving my j here, right? So now here, once my j move here, so now again I'm going to check what? So I'm going to check if 2 here and 4 6 is valid or not. So 2 4 and 6, so tell me, this is valid or not? 2 4 6, no, 6 is not greater than 6, no, it is not valid. So if this is not valid, then in that case what I'm going to do, it's not valid, right? So in that case what I'm going to do, so I'm going to increase some value, right? So this is 2, right? So if I increase this value, then maybe I get some better result. So I'm moving my I to the next position, so my I is going to reach here. So now in this case, now I have 3 4 and 6, right? So here I'm going to check 3 4 and 6. So here, yes, 3 plus 4 is greater than 6, so this is valid. So this is valid. So here what I'm going to get, my j minus I, now j minus I value, I'm going to get 1, right? So that simply means this 3 4 6 is valid, right? So this is done. And then after that, only after that, only I have to run until my I is less than j, right? So now after that, it's not like I'm going to decrement my j here, right? So I was decrementing j, right, when I find this 3 5 6 2 5 6 3 5 6 and 4 5 6. Now after that I have moved j here, right? So I was taking 2 4 6, I decrementing j, but now it is not valid, right? If I move j here, then my I is not less than j. So that's it. So this is done. So this is done. So here in these cases, if you see, this is my c value, right? This is my c value that is fixed, and here I'm checking all other pairs. So I'm only going to get all these pairs: 2 5 6 3 5 6 4 5 6 and 3 4. I'm directly getting the count. I'm not iterating over all the elements. I'm just using the 2 pointers approach, right? Now next time what I have to do, I'm moving my k to the previous position. So now my k is going to move here. So now when my k is going to move here, then again I have to start my I from here 0, and my j is from here, that is k minus 1. So now I'm going to check 2 plus 4. 2 plus 4 is greater than 5. Yes, right? So here 2 4 5 is valid, right? Same way, if 2 4 5 here it is valid, this is bigger, right? So here if in place of 2 I am writing some bigger value, right? If I'm writing 3, then 3 4 5 is also going to be valid only, right? So these two are the valid. So how I'm going to directly get them? So j minus I. So j is 2 and I is 0. So 2 minus 0 is 2. So I'm getting 2 here. So this is done. So these two are valid. Now after that, I'm going to move my j here. So now 2 plus 3 is greater than 5. No, right? It is not. So after that, my j is going to again move backward. So I is less than j only I need, right? If I is less than j, I have to stop my while loop. So this is done. Now next time, my k is going to move here. My k is going to move here. So if my k is here, they I have to take here and I have to take here. So this is also valid 2 3 4, right? So here j minus I in this case is going to be 1, right? So 2 3 4 is valid, and then after that, j I can't move, right? So now after that, k, no, I can't move my k here, right? Because if I move my k here as my c, then in that case I can't pick a and b, right? I need two values, so I have to run k until here only, right? So what are the values ones? We are going to get 2 3 4 also here, right? So in total 3 4 5 6 7, right? 1 2 3 4 5 6 7. Yes, that's it. So let's write the code. Very simple, nothing complex here. So let's write the code with the second approach, better approach. So here this is my nums, right? So here create one variable n as nums dot length, and here after that sort the arrays dot sort nums, right? So once we did the sorting, then after that create one variable count and set it to 0, and then after that you have to just simply run one k loop. Int k is equal to n minus 1, and then k value, it should be greater than equal to 2, and here k minus minus, right? So this is how I have to run k loop. And now inside this I have to start my I from 0, and I have to give the value of j as k minus 1, right? This is what I was doing, right? And here I just to make sure that my I should be less than j value, and inside this I'm just going to check if my nums of I value, nums of I value plus nums of j value, right? If this value is greater than the nums of k value, then in that case what I have to do, I have to increment my count as here j minus I, right? And then here I have to do j minus minus. This is what I was doing. So if this was not the case, then I was just incrementing the I, right? So that's it, and in the end we have just simply written count here. That's it. So this is the approach 2, right? So now let's run the code and see if their code should try to fix that. So yes, there are some issues. So here count, initially we have to give it 0, right? So let's run it again and let's see. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So let's see the time complexity from here. So we are getting n square, right? So overall time complexity is nothing but n square plus this n log n, right? We are ignoring this because we are just taking off n square. So I hope that you guys are clear with this 2 pointers approach, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.